Today we're going to be going over the sine graph. I'm going to save the cosine graphs for tomorrow. So as you are going through your notes with this video, just the sine graphs, add any extra notes that you need to. We did start our foldable in class today, or if we haven't started it in class, we will. Add any notes that you need to for your graphing foldable, things that you're for sure going to want to put on your cheat sheet for the test for the end of this chapter. If you want to regraph these, get out a piece of graph paper, get out your unit circle so you know where I'm getting some of this stuff from. I'm really not going to be using a calculator through this because I am going to be using my unit circle to create the sine graph. So let's start pretty simple. We did cover this last year in Math 3 pretty extensively, the sine graph. From 6.3, we know our domain is negative infinity to infinity and our range is negative 1 to 1. We also know that it is an odd function, therefore it is symmetric to the origin. We also know that one cycle is 2 pi. 2 pi because one full revolution of the circle is 360 degrees, and in radians that is 2 pi. Okay, I had to pause for a minute and it was like a 20-minute break, so let me get my train of thought going again. So we finished talking about domain, range, odd, symmetric to the origin, and that a full cycle of the circle is 2 pi. So we have our basic equation of a sine graph. The coefficient of sine always represents your amplitude, which is how far above and below from the midline you are. And the midline is the middle of, it's a horizontal line that runs directly down the middle of a sine and a cosine graph. When you are identifying your amplitude, it is always a positive value since we are talking about a distance. And then the omega helps you find your period. It's 2 pi for the entire cycle of a circle, and you're going to divide it by that omega. That's how often your graph is going to cycle through. So it could be faster than 2 pi, it could be slower than 2 pi. It just depends on what omega is. If your front value is negative, your amplitude is still positive. The negative, just like every other graph, is a reflection over the x-axis. So it is going to reflect your graph in the opposite direction over the x-axis. Now, if you haven't grabbed your unit circle, pause this, get your unit circle. I need you to understand where I'm getting the values from for this first sine graph. So when I'm looking at this sine graph, there is not a coefficient that I can see in front of sine, which means there's an invisible 1. So my amplitude is 1. When I am looking at the x, again, there's no visible value in front of x. So my omega is also 1. So here's my amplitude, here's my omega. So my period is 2 pi over omega, which is 2 pi over 1. So my period is 2 pi. So now I'm going to set up my coordinate plane. I need you to be very careful when you are setting this up. So I'm going to have 4 marks here, and that 4th mark is always, for me, going to be 2 pi. It doesn't matter what the entire period is of the function. No matter what, my 4th mark is always going to be 2 pi. If my period changes, I will extend my graph. That's not a big deal, but it will always be 2 pi. So half of that is pi. So a quarter is pi over 2. And then that makes us 3 pi, not over 3, over 2. And then backwards on this side, just like on the x-axis, we're going to have negatives. And then we have 1, 2, negative 1, negative 2. Please make sure when you are creating your coordinate planes that you are very clear in identifying what the scale of your graph is. Now, with your unit circle, I'm looking at my unit circle, and I'm going to start at 0. Go to 0 radians, please. The sign at 0 is 0. And don't forget, the sign is the y value. Now go to pi over 2. What is the sign at pi over 2? 1. Go to pi. The sign at pi is 0. Go to 3 pi over 2, -1. Go back to 2 pi, we're at 0. So I see the curve that's taking place, and it should be a curve. We're talking about how something is moving around a circle over and over and over again. Smooth, continuous. If you look at the hands of the clock in our classroom, you can see that those hands, 3 hands, move at different speed. That's your period. They are never going to stop unless the clock breaks, but ideally those hands keep going forever. So our graph does extend in both directions forever. When you are drawing your graphs, though, I do want to see 2 full cycles. I don't care how big your graph is, whatever the period is, I want at least 2 full cycles. You're welcome to draw more, but you are not welcome to draw less. Since sine is an odd function, it is symmetric to the origin, which means your points are going to change. So 0, 0 stays 0, 0. This pi over 2 becomes negative pi over 2. It was at 1, so now it's at -1. But again, symmetric to the origin. So I'm going to use my knowledge of that. This point at 3 pi over 2 is down at -1, so it'll be up at 1 here. So I have my nice smooth curve. That's not going to be super smooth. Now, I'm not looking for perfection, you guys. Take your time. You do need to put arrows. These are continuous. So the arrows identify that these are going in both directions. They're not going to stop. As we pointed out in class today, there's some key points here. Let's talk about our x-intercepts. Our x-intercepts are at, now let's just look at one cycle. So here's one cycle from here to here. Your x-intercepts occur, so your zeros are at the beginning of the cycle, the end of the cycle, and in the middle. So I'm going to start, I'm going to end, and I am going to have a middle at 0. Super, super important. We want to identify our x-intercepts everywhere that x equals 0. Or, well, in this case, the sign is 0. Knowing that, it's going to make your life easier. Even if we have a vertical shift where the graph moves up and down, all that does is move your midline. Your zeros will still happen on the midline. They just won't happen on the x-axis this time. And that will come later. That's the last one we're going to discuss today. The next thing I notice is my amplitude. So once I have my zeros, I want to graph my amplitude. So I'm going to put another mark at the middle. So there were my 3 zeros. The amplitude, like has been said in class, it's the middle of the middles. Your zeros break your graph up into 2 sections, 2 equal sections. One part has the amplitude going up in the middle, and the other part has the amplitude going down in the middle. So that's going to be the second thing that you would graph. So you would start with your zeros, and then the second thing is the amplitude. And that happens in between the zeros. So it's the middle of zeros. So you're going to start up, then down. Now, if your leading coefficient is negative, then that's when your graph would start down and then go up. So I'm going to make a note of that. If you have negative a sine of omega x, you are going to start, if I can spell it, start down, then you're going to go up. So lots of things that we need to make sure we remember and pay attention to. And if you haven't added this to your foldable yet, you need to. And it might be something you want to transfer to your cheat sheet for our assessment for the chapter. All right, let's take this and apply it to another graph. Actually, let's do example 1. This is not graphing. Here you guys are going to just determine the amplitude and the period. And it's the same thing. Whether it's a sine or a cosine graph, amplitude and period are the same. So let's go ahead and do that. Here, my amplitude is 2. Comes from the coefficient. Period is 2 pi over omega. Here is your omega. So 2 pi over 1 is 2 pi. In B, even though it's a negative 3, your amplitude is still 3. Period. Here's my omega. 2 pi over 3. I can't simplify that, so it's going to stay 2 pi over 3. And then in C, my amplitude is 4/3, which is 1 1/3 when I go to graph this. Otherwise, it's 4/3. Period. 2 pi over 2/3. So I'm going to flip and take the reciprocal of the 2/3 and multiply. So I get 2 pi times 3 over 2. 6 pi over 2 is 3 pi. So that's got a nice long period. So the graph is going to be relatively slow. Okay, let's graph sines. Start by identifying your amplitude. We're going to do cosines tomorrow. So amplitude, my coefficient is a -1, so my amplitude is 1. The negative tells me this is going to go down first. To find the period, hold on, let me take off my bracelet. It keeps making all kinds of noise on the computer, and you guys are probably hearing it. And it's driving me bonkers, so it's probably driving you bonkers. Okay, now the period, 2 pi, your omega is 2. So our period, ignore this over here. Our period is pi. 2's cancel. So I'm going to start by labeling my coordinate plane. So remember, no matter what my period is, my fourth mark is 2 pi. Pi. Negative pi. Negative 2 pi. 1, 2. Negative 1, negative 2. Sorry if you can't see that too well. Zoom it in if you need to. I'll zoom it in for you. There we go. Now, I don't need my unit circle for this. I could start taking values and plugging them in. I could plug in 0. I can plug in pi. I can plug in 2 pi. I can plug in pi over 2. I can plug in pi over 6. I can plug in pi over 3. You can plug in a bunch of values for x, but I'm going to use those nice things that we talked about for the sine graph. I looked at, well, and this is experience also, patterns that I've always seen in the sine graph. So our sine graph starts at 0, 0. What was the period? The period was pi. The period is the end of the graph. So there's the end. So I have the start and I have the end. The next thing I want to graph is the middle. So I want the middle of these two, which is right there. So now I have my two parts. I'm going to go to the middle of this first one. I'm going to eyeball it. And my amplitude was 1. But don't forget, because it was a negative, I need to go down in the downward direction first. So I have the middle, go down to 1, go to the other section, middle, up to 1. And there's my first cycle. And I can continue it over here. Follow the same pattern. There's so much symmetry. Again, we're talking movement around a circle. And then it's symmetric to the origin. I'm following the pattern from the other side. Just up, down, up, down, up, down. Don't forget your arrows, and there's your graph. You can see that this is a lot faster than the last one. The last one, don't draw this, but the last one went like this. So very slow for the original sine compared to this one. Period was pi. This is twice as fast because there are 2 cycles within this one. Very, very fast. Well, not very, very, but it's faster. Okay, let's go to the next one. So now we're on C. Let's start with the period. Sorry, amplitude. I don't know why I said period. Amplitude is 3. Period. 2 pi over 4, which is pi over 2. Okay, this one's going to be super fast. So let me fill this in. 1, 2, 3, 4, 2 pi, pi. Negative pi, negative 2 pi. Oh boy. Well, this says pi over 2 is my period. So pi over 2 happens in the middle of pi. Okay. I hope you're watching closely. Oh, I forgot to label my amplitude, you guys. 1, 2, 3. 1, 2, negative 3. Okay, now I'm ready. So I start at 0, 0. My end is the cycle, the period. So pi over 2. Now please watch. I need to find the middle first. That's at pi over 4, right there. There's my middle. This is going to be an absolute mess, you guys. This is going to look so sloppy. If we were to graph this in Desmos, it would be beautiful. Here it's going to look a little weird. So I go to the middle of this. You have 2 sections. I go to the middle of the first one. My amplitude is 3. Go to the middle of the second one. My amplitude is negative 3. That is 1 cycle. Oh my goodness. Now I'm going to draw another one just so you guys can see this. There's another period. Halfway. Halfway up at 3. Halfway down at negative 3. Please forgive me if I mess this up. I'm sorry. Desmos would do this so much better. They are going to look like V's because I'm having to graph this so close. There we go. Now you can see how squashed it is because it's happening so fast. And you can see how stretched it is because our amplitude is 3. Now I'm going to just draw one more cycle on the negative side. My period goes to negative pi over 2, halfway through. Now this one's going to go down to negative 3, and this other half goes up to 3. And then I can finish this. And it's going to connect there. Again, Desmos would do this beautifully. It's inhuman. It's not going to make a mistake. It's going to be perfect. But it's very, very fast. But they're not difficult to graph, you guys. They look maybe a little complicated and a little bit intimidating, but they're not. I see the period of pi over 2, and I see the amplitude of 3. Here's our cycle, you guys. Whoops, I thought I hit highlighter. Here's the cycle right there. So I see the period and I see the amplitude. All right, let's see if we have any more sine graphs. That's a cosine graph. Ooh, there's a sine graph. Okay, this sine graph is a little different. Still going to find the amplitude, still going to find the period, but I'm going to graph this a little differently because it has a vertical shift. Up 4. So I am actually going to talk to you right now about the midline. My amplitude is 6. My period, I'm actually going to have to change. Let me change the, there it goes. Okay. My amplitude is negative, which is going to make the graph start down first. My period is 2 pi over 3. Reciprocal. Let me bring this over here. I still think I'm going to have to move it. Okay. So this becomes 2 pi times 3. Whoa. 3 over pi. Pi's cancel, and I'm left with 6. So my amplitude is 6, my period is 6. That's actually nice. I don't have to deal with radians here. Oh boy, let me just remake that. Give me a moment. Okay. So 1, 2, 3, 4, 5, 6. It's that easy. When you don't have pi, just use the normal coordinate plane that we're used to. It's still radians. It's still 6 radians. The pi just happened to cancel. 1, 2, 3, 4, 5, 6. Negative 6. Let me see how we're doing on time. Okay. The positive 4 moves your midline. Where your midline is normally right here. It runs right down the middle of the graph horizontally. That positive 4 moves your midline up 4. So I'm going to draw my midline as a dashed line. Now it's not an asymptote. It's just midline. That's going to be the center of your sine graph. Everything got moved up 4. So instead of starting at 0, 0, I'm going to start my graph where 0, 0 would be, but on the midline. My period, which is 6, is still going to be my end, but instead of ending on the x-axis, we're going to end on the midline. So it's still the same idea. Then I find the middle. Then it's the middle of the middles to graph your amplitude. So this is where you need to be careful. You don't go to 6. You go up 6 from the midline and down 6 from the midline. And I have a negative in front, so that means we have to go down first. So I'm going to eyeball the middle right here. Now, please watch. Whatever you're doing, stop and watch. 1, 2, 3, 4, 5, 6. There's your point for the amplitude. I went down because it was negative, and it's 6 from the midline. Now I'm going to go the middle of these two. 1, 2, 3, 4, 5, 6. I'm trying to save you guys time. Come on. I'm trying to save you guys time from having to create the sine graph with the amplitude and the period and then shifting everything up 4. That is just, it's time consuming. Don't even do that. So I have my graph. Pretend I went through all the points perfectly. Now I need to draw the second cycle, but I want it on the negative side. So I'm at -6, and then I go to -3, halfway, 1, 2, 3, 4, 5, 6, halfway, 1, 2, 3, 4, 5, 6. And then I have the rest of the cycle. And that's a sine graph with a vertical shift up 4. As you guys are working through these, and you guys should just be doing the sine graphs tonight, as you're working through them, if you want to, plug into Desmos as well. Check your graphs on Desmos so you don't have to keep flipping to the back of the book. And if it's an even question that I gave you, and even if you want to play around with some of the even graphs just for more practice, because this is something you do need to get. If you can graph the sine graph, you can graph cosine, you can graph secant, you can graph cosecant. It's very important. Sine graph is an extremely important graph. And so is cosine. Cosine's going to be the second video, and in cosine, we'll go ahead and do example 3 with that as well. If you have questions, please write them down so you can get them asked before we move on to the cosine graph tomorrow. I hope this helped. If you need to watch it again, watch it again. If you have more questions, please make sure you do ask. And I'll see you tomorrow.